Hello friends, welcome to the tutorial series on network analysis made simple. In this tutorial, we shall solve gate questions on network reduction using equipotential concept. Friends, observe the network shown in figure. We are required to find the magnitude of the current I in amperes. The supply voltage is 11 volts. Let us decide to find the equivalent resistance RAB using equipotential concept. To find the equipotential points, we need to identify the source terminals and the load terminals in the network. Since we want to find RAB, A and B are the source terminals. By observing the network, we find that there are two pair of load terminals and they are C and D and E and F. First, let us check C and D for their equipotentiality. Path resistance from C to A is equal to R1 and from D to A also is equal to R1. Similarly, path resistance from C to B is equal to R1, R1 and from D to B also is equal to R1, R1. So, C and D are the equipotential points. Next, we shall check E and F for equipotentiality. Path resistance from E to A is equal to R1, R1 and from F to A also is equal to R1, R1. Similarly, path resistance from E to B is equal to R1 and from F to B also is equal to R1. So, E and F also are equipotential points. So, we shall short both C and D and E and F as shown in figure. Friends, the circuit after shorting C and D and E and F is shown in figure. It is given that R1 is equal to 1 ohm and R3 is equal to 3 ohm. By inserting these values, the circuit drawn is shown in figure. You know the resistance R2 are short circuited. We find that 3 ohm and 1 ohm are in parallel across C and E and their equivalent is 3 by 4 ohm as shown in figure. Similarly, another 3 ohm and 1 ohm are in parallel across D and F and their equivalent also is 3 by 4 ohm as shown in figure. Further, 1 ohm and 1 ohm connected to A are in parallel and their equivalent is 1 by 2 ohm. Also, 1 ohm and 1 ohm connected to B are in parallel and their equivalent also is equal to 1 by 2 ohm as shown in figure. The reduced circuit drawn is shown in figure. We find that 1 by 2, 3 by 8 and 1 by 2 are in series across A and B and their equivalent resistance is 11 by 8 ohm. Finally, we see that current I is equal to 11 volts divided by 11 divided by 8 ohm or 11 into 8 divided by 11, hence I is equal to 8 amperes. Hope it is clear to you. Friends, we are required to find the equivalent resistance RAB in the network shown in figure. According to me, this problem is important in view of knowing which load points are not equipotential points. We know A and B are supply terminals and there are two pair of load terminals and they are C and D and E and F. First, let us check equipotentiality for E and F load points. We find that path resistance from E to A is 20 ohm and from E to B is 10, 20 ohm. Since both path resistance are not same, the load points E and F are not equipotential points. Please note this. But if we check the load points C and D, we find that path resistance from C to A is 10 ohm and from C to B also is 10 ohm. Similarly, path resistance from D to A is 10, 20 ohm and from D to B also is 10, 20 ohm. Hence, load points C and D are equipotential points. So, let us open C and D as shown in figure. We find that 10 ohm and 10 ohm are in series and their equivalent is 20 ohm. Another 10 ohm and 10 ohm also are in series and their equivalent also is 20 ohm as shown in figure. Incorporating these results, let us draw the reduced circuit. Friends, the reduced circuit diagram is shown in figure. Observe the circuit. We find that 20 ohm and 10 ohm are in parallel across E and F and their equivalent is 20 divided by 3 ohm. Now we find that 20 ohm and 20 divided by 3 ohm and another 20 ohm are in series and their equivalent is 140 divided by 3 ohm as shown in figure. Finally, we find that 20 ohm, 140 divided by 3 ohm and 10 ohm are in parallel and their equivalent is 35 divided by 6 ohm. Hence, equivalent resistance across A and B is 35 divided by 6 ohm. Friends, in this problem, we are required to find current delivered by the voltage source of 2 volts. Let us solve this problem without using star delta conversion but using the equipotential concept. Observe the network. The supply points are A and B and there are 2 load points and they are C and D and D and E. First, let us check the load points C and D for their equipotentiality. Path resistance from C to A is 6 ohm and from C to B also is 6 ohm. Similarly, path resistance from D to A is 3 ohm and from D to B also is 3 ohm. Hence, C and D are equipotential points. Next, let us check load points D and E for their equipotentiality. Path resistance from D to A is 3 ohm and from D to B also is 3 ohm. Similarly, path resistance from E to A is 2 ohm and from E to B also is 2 ohm. Hence, D and E also are equipotential points. Now, let us open both 7 ohm and 8 ohm resistance as shown in figure. Now, 6 ohm and 6 ohm are in series and their equivalent is 12 ohm. In other branch, 3 ohm and 3 ohm are in series and their equivalent is 6 ohm. In another branch, 2 ohm and 2 ohm are in series and their equivalent is 4 ohm. Finally, we find that 12 ohm, 6 ohm and 4 ohm are in parallel and their equivalent is 2 ohm as shown in figure. Hence, current delivered by 2 volt source is 2 volts divided by 2 ohm equal to 1 ampere. Very easy, isn't it? Friends, I am sure you have clearly understood the concept of identifying the equipotential points in the resistive networks. Hope this tutorial has kindled some of your thoughts, and I hope you have enjoyed the presentation. In subsequent tutorials, we shall meet and solve some more interesting problems. Thank you for watching.